To row reduce a matrix, it's not enough to know the allowed operations, which are shown here. You also need a strategy in order to achieve your goal. In that way, row reduction is a lot like a game. In this lesson, I'll show you a strategy using an example of an augmented matrix, which might result when you are trying to solve a system of 3 equations in 3 unknowns. Suppose we have this given augmented matrix. What we want is to transform the matrix into a matrix of this form. Notice the ones down the diagonal, and zeros above and below the diagonal, and then some numbers on the right-hand side, the augmented side. Or, if we could only get some numbers down the diagonal with zeros above and below, then we could divide by those numbers to get the ones. Okay, what we want to do is to first look at row 1. It starts with a non-zero element, and then use linear combinations of row 1 with rows 2 and 3 so that we get zeros in that first column below the first entry. Like that. And when we finished with row 1, we want to move to row 2, which starts with a 0, and take the first non-zero entry to clear zeros above and below it. In other words, we will use a linear combination of row 2 with row 1 and with row 3 to get zeros above and below the non-zero entry of row 2. And then finally we move to row 3, which has a non-zero entry in the third position, and then use linear combinations of row 3 with rows 1 and 2 to get zeros above that non-zero entry of row 3. Like this. That's going to be our strategy. Now notice that when we've done this, we get a lower triangle of zeros and an upper triangle of zeros and a diagonal of non-zero numbers. Okay, so let's go back to our given matrix and do those operations. We start with row 1, and its non-zero entry at the beginning there, and we want to use a combination of row 1 with row 2 to eliminate that 4 there in row 2. We want the 4 to become a 0. So let's see, we have to use a linear combination of row 1 with row 2 in order to achieve that. If I multiply row 1 by 2 and subtract that from the old row 2, then I'll get a 0 in that position. So let's write out what we have. The old row 2 is shown there, and then we're going to subtract twice row 1 from it to get a new row 2. And then we replace row 2 with the new row 2. Oh, wait a minute. Let's multiply by -1. I hate starting with a negative there. So we're going to replace row 2 with this new row 2 here. And there we go. Okay, now we want to use row 1 to eliminate the 8 in row 3. So let's see. What we could do is for our new row 3, we could take the old row 3 and subtract 4 times row 1. And that gives us this. So the new row 3 would be 0, negative 15, negative 6, and 2. Let's not multiply by negative 1 this time. Let's just leave it as it is. We'll replace row 3 with this new row 3. And that's good enough. Kind of like that negative 15 there. Maybe that will make things easier later on. I don't know. Okay, now we move to row 2. And we are going to use row 2 to clear zeros above and below the 15 there. So let's see, we're going to combine it with row 1 first. And we want to combine the 15 and 6 to end up with 0. Let's see, this is like finding a common denominator when you're adding fractions. If I multiply 15 by 2, I get 30. And multiply 6 by 5, I get 30. So let's see, what we could do is for our new row 1, we could do 5 times the old row 1, that'll give a 30 there where the 6 is, minus 2 times row 2. And that should work. So if I write that out, then I get, for the new row 1, I get the 0 in the position where I want it. So I want that 6 to become a 0, and that works. So we'll replace row 1 with the new row 1. Okay, we're still using row 2 to clear things. So we want to use it to clear the negative 15 there in row 3. Oh, and that's pretty easy. See, I can just add those. So the linear combination I want here is the new row 3 is equal to row 2 added to the old row 3. And if I do that, I'll get my 0 in that position. And there it is. There's the new row 3. Notice it starts with 2 zeros there. So we replace the row 3 with the new row 3. And there we have it. Okay, now we're getting very close to being finished. So we used rows 1 and row 2 to clear things. We're going to use row 3 to clear zeros above the first non-zero entry there. So if I use row 3 with row 1 to get the 0 in the row 1 position where the negative 3 is, I just want to add those 2 rows. So the new row 1 is going to be the old row 1 plus row 3. And there's the old row 1 plus the row 3. And the new row 1 has the 0 in the position where I want it. Well, let's see. It has 10 and 15 in it. Those are divisible by 5. So let's divide by 5. And then that gives us the new row 1, which we can now replace. And we have this. Okay, we've got one more step to do. We want row 2 to have a 0 where the 9 is, so we will do something with the 3 and the 9. Let's see, if we do the old row 2 minus 3 times row 3, that'll get the 0 there where the 9 is. So what we have is row 2 minus 3 row 3, and we do get rid of the 9 there. And again, we can divide by 5 to make a simpler new row 2. And so if we do that, we get the simpler new row 2 like this. And now we have our lower and upper triangle of zeros, and we have the diagonal with non-zero entries. To finish it off, we'd like to have 1s on that diagonal. So what we can do is we can divide row 1 by 2, and we can divide rows 2 and 3 by 3. And there we have our row-reduced augmented matrix, and so if you're using it to solve a system of equations in x, y, and z, it would say that x is 3/2, y is -2/3, and z is 4/3. I do want to make one more remark about this. If at some point you end up with a 0 on the diagonal, like in this example, then you should swap that row with another row so the 0 is no longer on the diagonal. So we would swap, say, these two rows here, and then we end up with something that does not have the 0 on the diagonal, and then you proceed as before. And that's basically how you do it. The strategy is to get your lower and upper triangles of zeros there and non-zero diagonal.